Good morning, students. Can you hear me? Students, can you hear me?
Yes, ma'am.
Only 14 have joined. I think still more to join. First hour is over, right? So we'll wait for 2 more minutes. I think the parallel students have not joined yet. Answer your attendance. Karan,
Present, ma'am.
Karuna,
Yes, ma'am.
Kavyashri,
Yes, ma'am.
Kirtana,
Yes, ma'am.
Kriti,
Present, ma'am.
Loshika,
Present, ma'am.
Manish,
Present, ma'am.
Manjusha,
Present, ma'am.
Mervin, Mervin is absent. Melroy,
Present, ma'am.
Rashik,
Present, ma'am.
Murtaza, Nagashri,
Present, ma'am.
Neil,
Present, ma'am.
Nolan, Nolan Pinto, absent.
Present, ma'am. Present, ma'am.
Pavan, yeah, Pavan, Purva, Purva,
Yes, ma'am.
Pragati, Pragati, Pragati is not there. Prapti,
Present, ma'am.
do we have parallel students? Diksha,
Yes, ma'am.
Ranson, Ranson, Ashika,
Present, ma'am.
Harshit, Harshit, Sharon, so the absentees are, I think Mervin is there. Murtaza is not.
Present, ma'am.
Yeah, who is that? Mervin, right?
Yes, ma'am.
Pragati is there.
Yes, ma'am.
Okay, so Murtaza is absent. Then Ranson, Harshit, and Sharon.
Present, ma'am.
Who is that?
Diksha Rao.
What about Ranson?
Present, ma'am.
Harshit. Harshit. Sharon is there. What about Harshit? Harshit is also there. Okay. So only Murtaza is absent. So welcome to the first session of the Embedded System Lab. Can see the screen, right?
Yes, ma'am.
So the course name is Embedded Systems Lab. Course code is 18ECL66. Coming to the syllabus, we have part A and part B. In part A, we have experiments to learn assembly language programming using ARM Cortex-M3 registers using an evaluation board and the required software tool. Okay, so mainly in part A, we are studying assembly language programming, okay, which is written using ARM Cortex-M3 instruction set. And software we are using for part A is Keel Microvision software. I think all of you have used Keel software earlier, right? Am I right? Have you used Keel software earlier?
Yes, ma'am.
Yes, ma'am.
For what you had used?
8051. I mean,
Okay, for 8051 microcontroller. So you are not very new to the microcontroller concept. So the experiments are ALP to multiply to 16-bit binary numbers, ALP to find the sum of first 10 integer numbers, ALP to find number of zeros and ones in 32-bit data, ALP to find given 16-bit number is even or odd, ALP to write data to RAM. I think most of these experiments, I think almost all, you have done using in your 8051 lab, right? The logic remains the same. Here you have to make use of the instruction set of ARM Cortex-M3. Right? Instructions will be different. Logic remains the same. Very small programs, okay, simple programs. So this is about part A using Keel Microvision software, which is an assembler to convert assembly language programs into machine or object code. In part B, you have experiments to be conducted on ARM Cortex-M3 evaluation board using evaluation version of Embedded C and Keel Microvision 4 compiler. So, okay, so these are the interfacing experiments, okay, interfacing experiments which are written in Embedded C. Okay, so the first experiment is to display hello world, okay, using internal UART. All of you know what is UART, right? Universal Asynchronous Receiver Transmitter. And the interface and control a DC motor, interface a stepper motor and rotate it in clockwise and anti-clockwise direction, interface digital to analog converter and generate triangular and square waveforms, interface 4x4 keyboard and display the key code in LCD, demonstrate the use of external interrupt to toggle an LED on and off, display hex digits 0 to F on a 7-segment LED interface, measure the ambient temperature using a sensor and SPI ADC IC. So you can see all are interfacing experiments. These are actually the examples of embedded system, right? Each one of this is an embedded system, you can say. What is embedded system? System on chip, right? So here microprocessor used is ARM Cortex-M3. ARM Cortex-M3 alone will not be able to execute these because to interface what you need mainly, what you need to interface something to a microprocessor, you have a hardware components, you have a microprocessor. What do you need in between? You have done some of this in the lab, right? You have studied 8051 microcontroller, DC motor, stepper motor, I think even 4x4 keyboard you have interfaced, right? You need input-output ports, right? So processor will not have input-output ports, right? So you need a microcontroller. Microcontroller is required to interface input-output devices because microcontroller will have memory as well as input-output ports and many more features. And ARM Cortex-M3 is just a central processing unit, right? So the controller should have some processor in it. We are using LPC1768 controller, which has ARM Cortex-M3 processor or core in it. So the program is written using embedded C for the LPC1768 microcontroller, which is based on ARM Cortex-M3 processor. Okay. So this is about the hardware experiments, mainly to explore about the embedded systems. Okay, so the textbook. You can refer to the textbook of Joseph Yu on Definitive Guide to the ARM Cortex-M3. Right? This is the textbook you have for your theory also, right? And for the embedded system, you can refer to the Instruction to Embedded Systems, where you can study about all the hardware components such as the stepper motor, DC motor, 7-segment display, how these are interfaced with the microcontroller. Okay, you have the theory there. You have theory in theory of these interfacing in your lab also. Okay, how these hardware components are interfaced with the LPC1768 microcontroller, which ports are used, there are how many ports, how they are used, all that you will be studying in the theory. Okay, theory of the lab. So, and these are the same textbook you are referring for your theory also, right? The ARM part you will be referring to the first textbook, and for the embedded system part you will be referring to the second textbook in your theory. So other than this, you can refer to some online resources. Okay, the first link is for NPTEL course on embedded system design using ARM. And then you have a website of Keel, where you can find different softwares. Okay, till date, what are the softwares available by Keel? Okay, and then the software used for the current lab is also can be downloaded from this particular website. But I will also be sharing. You can directly take the link from the Canvas. And then there is one more link for ARM website. Okay, so here you can see the different processors which are designed by ARM. Okay, so what is the latest processor, you can check there. So many resources, even the instruction set for different ARM processors manufactured or designed by the ARM company is available there. So always you can explore on these concepts. Not only these, you will get many more resources in the website. So main thing is you should not confine yourself for the explanation given by the lecturer. Always you have to explore more, okay, and find out the facts for yourself. So that is the main idea. These are the course outcomes. What are the outcomes expected by you at the end of the lab? The first one is to the student will be able to identify the details of the architecture of LPC1768 microcontroller, understand the instruction set of ARM Cortex-M3, and software tools required for assembly language programming. Okay. Students will be able to program ARM Cortex-M3 using various instructions in assembly language and understand basic operations using ARM Cortex-M3 instruction set. Also to program Cortex-M3 in C language for controlling hardware components such as stepper motor, DC motor, transmission and reception of data using internal UART, and demonstrate application of hex keypad. Students will be able to interface ARM Cortex-M3 and analyze the usage and applications of 4x4 keyboard and DAC interface. Program the microcontroller to control LED using interrupts, 7-segment display and temperature sensor. And also to demonstrate an open-ended experiment using hardware components which are embedded in LPC1768 microcontroller. So the CO1 to 5 are from the lab syllabus. Okay, they are the outcomes of studying the lab syllabus, and the sixth one is the outcome based on the open-ended experiment. Student will be able to do an open-ended experiment. This will be considered as one extra experiment. For example, if you have 10 experiment, 11th one will be open-ended, which all of you have to do compulsorily. And since it is open-ended, you are free to come up with any idea, okay, for an open-ended experiment. Okay, it is left to you. You are free to do any program as an open-ended experiment. It can be an assembly or it can be a C program. Okay, but when it is C program, you have to check whether the hardware required for the experiment selected by you is already available, because LPC768 microcontroller, which we are using in the lab, supports fixed hardware components which are used in the lab. They are already integrated in the kit, okay, lab kit. So the program should be compatible with the hardwares which are already present. So by the end of the 5th week of the lab, you should be ready with your idea. Okay, by the end of the 5th week, which experiment you are doing as an open-end experiment, you should be ready with the idea, and then you need not wait for the end till the experiments are completed. You can do it in between also. It is left to you. Okay, so but it is compulsory and it is individual, okay, not the group assignment. About the lab rubrics, now here I would like to mention about the conduction of the lab, how the online lab will be conducted. So as you know, there are 5 hours in the theory allotted for the ARM subject. Out of that, 2 hours are used as a lab tutorial, right? Staff in charge is Mahesh sir. He'll be taking 2 hours per week as a lab tutorial, where he will be explaining the instruction set and also the lab programs. The code of any lab experiments will not be made available to you. Sir will be explaining how to write the program, the syntax, the logic behind it. You have to write your own code. Okay, so for example, if you have the lab in the next week, this week the programs for the next week lab will be discussed in the theory, so that you will get sufficient time to write the program. And then in the regular lab slots, you will be assessed for the performance and viva. So you have a first criteria as performance, where you will be assessed for your program execution, design of logic, okay, how the program is written, whether it is correctly written with no correctly executed with no syntax or runtime errors, program is logically well designed. So based on your performance, you have different range of marks. Okay, so the student will be joining one by one based on your USN, okay, and demonstrating the execution of the software in their own system, and you will be evaluated for this 10 marks. And then based on the question answers, okay, how well the student is able to answer the questions asked by the faculty, 5 marks of viva will be given. So you will be assessed for these 15 marks, 10 marks of performance, that is for the program execution, and 5 marks of viva. Okay, so this documentation marks, these marks are for the report writing. But since we don't know about the offline labs, this particular aspect is under discussion, how to assess for documentation. Documentation means the program with the comments and the output is neatly documented. Program with comments and the neatly documented output. So for that 10 marks are given. So I will let you know through the Canvas, okay, how we are going to assess the documentation part of it. I may share the link, okay, of the folders batch wise, in which you may have to upload the typewritten program, not the handwritten, typewritten programs along with the comments and the output written. Okay, and it will be evaluated, and then the marks of documentation also will be given. So anyway, I will let you know about this. But for time being, in the regular labs, you will be assessed for 15 marks, 10 marks for the execution, 5 marks for viva, and for documentation 10 marks. And how to go about this, I will let you know later after the discussion with the co-faculties and the HODs. Okay. So anything about the conduction you would like to ask? I hope all of you are having laptop or desktops with you. Anyone who is not having? In the regular lab, you will be joining individually. Maybe 7 to 10 minutes will be taken for each student. So one by one, you have to join, share your screen and show the execution and answer the Viva. And after your slot, you can leave. So like that it will be. So anyone who is having any problem with the system, please unmute yourself and tell me. So all are fine with this, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, thank you. Little bit about the instruction to ARM Cortex M3. This you already studied in the theory, right? In the very first class you might have studied, right? Am I right? Yes or no? ARM was founded in 1990 as Advanced RISC Machines Limited, right? Which is a joint venture of Apple Computer, Acorn Computer, and VLSI Technology. And what M stands for? In ARM Cortex M3, M stands for 3 is a version, M stands for?
Microcontroller.
Yeah, it is a type of application in which this particular processor is used, right? What are the other versions? You have A and R. R is for real time, A is for
Application.
application. Yeah, it is mainly for complex applications oriented. So ARM Cortex M3, where M stands for embedded microcontroller type systems, and it uses thumb-2 instruction set, which is a combination of 16-bit thumb instructions and 32-bit ARM instructions. So it is called as thumb-2 instruction, which is a superset of the previous 16-bit thumb instruction set with additional 16-bit instruction along with the 32-bit instruction. Okay. Salient features of Cortex M3, it is a 32-bit microprocessor, right? 32-bit microprocessor. Be very clear about ARM Cortex M3. It is not microcontroller, it is microprocessor. 32, it has a 32-bit data bus, 32-bit register bank, 32-bit memory interfaces, hardware architecture, right? Separate memory for data as well as instruction, as well as dedicated buses. Thumb-2 instruction set is used. No switching between ARM state and thumb state because of using thumb-2 instruction set. All the instruction fetches are 32-bit. So up to 2 instructions can be fetched in one cycle if the instructions are 16-bit instructions. Then the main feature or most important feature is nested vector interrupt controller and the memory protection unit. Okay, because of which it is very much efficient than the other microprocessors. Then it can support up to 240 external interrupts. It makes use of 2 operational modes. One is user and one more is privileged. So user is used for the application programs and one more is to handle the handlers or interrupts, exception and interrupt handler programs. And it has advanced debug components. Coming to the LPC1768 microcontroller. LPC1768 microcontroller we are using in the lab, which is using ARM Cortex M3 processor. So it is called as ARM Cortex M3 based microcontroller for embedded application featuring high level of integration and low power consumption. LPC1768 is manufactured by NXP Semiconductors. So we are using a kit in the lab, right? The microcontroller is integrated in a kit which is named as VTCM32. So VT means Vasundhara Technologies, which are the manufacturers and suppliers of this embedded controller kit, okay, in which we have LPC1768, which in turn uses ARM Cortex M3 processor. So Vasundhara Technologies Cortex M3 processor 2 is again a version. So it provides a hardware platform for developing embedded systems using LPC1768 device. So the kit will look like this. VTMC3 kit will look like this, and here you have LPC1768 microcontroller having ARM Cortex M3 processor in it, which is a 100-pin IC, and all the hardware experiments you are doing in your lab are supported by this kit. Okay, so you have a 7-segment display, you have LCD display, you have I2C, SPI, UART slots, USB, and then you have the keypad here 4x4 keypad, you have temperature sensor, you have drivers for DC motor as well as the stepper motor, okay, driver ICs, all experiments. This particular kit is mainly designed and manufactured for the lab, ARM Cortex M3 lab. Okay, so all those experiments are supported by this kit. So this is a LPC1768 IC. So we don't know about the offline lab whether you will be able to see this kit and do the experiments, but we can do all the experiments in the online mode. Only the dumping of the code into the controller will not be possible, but we can simulate all the experiments and check the values of the registers, GPIO ports, okay, general purpose input output ports. What are the values there? If the values at the input output ports are fine, then the hardware components which are connected to it will be successfully controlled, right? That means our execution is right. So we are going to simulate all the experiments, and if you get a chance to come to the offline lab, you can execute the C programs once again using this board and control the input output devices as per the experiments given in the syllabus. Okay, so for this embedded C programs of part B, you will be using both ARM Microvision software as well as FlashMagic. For part A experiments, those are the assembly language programs. You'll be using only Keil software, Keil Microvision. For part B, you will have Keil Microvision as well as FlashMagic software. Again, you are not very new to this, right? You have used both of the softwares for microcontroller. Here it will be for your integrated development environment. IDE is for controller-based applications. Okay, so this is about the lab. Now, right now, I have shared you the material for cycle 1. If you see the Canvas page of the embedded system lab, I have shared you Keil software. You can find the Keil software link here from which you can download and install and be ready for the lab. And then now we have the details of the software, the user manual of ARM Keil software. That all the details along with the steps of execution is available here. This is the user manual of the LPC1768 microcontroller. Okay, it has block diagram of the microcontroller, the pin diagram, and about the memory configuration, ports, input output ports, and the registers used by this microcontroller for interfacing. Then introductory material on ARM Cortex M3. Please go through these materials. Okay, you will get more knowledge on the software and the processor and the controller we are using in the lab, and also about the kit. Okay, the VTM-C3 kit. So this is the first week of the lab. This week we've had the instructions about the lab for all the batches. In the second week of the lab, starting from next Wednesday, since we started the lab from Wednesday, in the second week starting from the next Wednesday, the faculty will be demonstrating the Keil software. Okay, how to use Keil software for executing an assembly language program. So they'll be executing few experiments which are not the part of the syllabus, and they will be explaining how to see the memory locations and also the registers. And from the third week onwards, the regular lab assessment starts. So before that, the experiments of the first week and the instructions, protocol, syntax, everything would have been done in the theory. Okay, you will get sufficient time till the third week, and you have to write your code and you have to be ready to execute and show. You are not writing the code in the lab session, you will be executing and showing the output and explaining the program. So this is about the lab conduction, about the rubrics, about the material. Anything you would like to ask? So one more thing I would like to stress here is the attendance is directly documented in the attendance register. You know that the 85% attendance is compulsory. Your attendance, performance, viva, and the documentation marks, everything will go to the register, okay, which will not be changed for any reason, okay, later. So be serious about the assessments and also about the attendance. If you are, for any genuine reason, if you are not able to attend this lab session, you have to inform, because it will come under special category called as absent with permission. Okay, it is marked as AP. Okay, it is marked as AP in the attendance register. And for such cases, since the student is absent, performance and viva marks will be 0 by default. Documentation marks will be given when the student submits the report or the uploads the program. That about that I'll let you know anyway. So since it is absent with prior permission, that particular lab itself will be deducted when we take the average. So student will not lose any marks. Understood? If you are absent with prior permission, at the end when we take the average of your performance of marks, that particular lab, whenever you are absent with prior permission, will be deducted. Okay, for example, if there are 10 labs, for one of the lab you are absent with prior permission, you will be marked as AP. Performance and viva marks will be entered at 0, but when we take the average, your average will be taken for 9 labs. So you will not lose any points there. So that is only if you are absent with prior permission. If you are absent without prior permission, okay, out of 10 labs, you are present for 9 labs, 1 lab you are absent, your average will be taken out of 10 labs itself. So you will be losing the marks of the lab for which you are absent. I hope you have understood. And about this lab evaluation, again, it is present, okay, if you want to go through once again in the Canvas here, course evaluation plan. Okay, I have mentioned about this. Okay, here you will find the syllabus, the lab faculty syllabus. Okay, reference books, everything is available there. The course outcomes, topic learning outcomes, then the evaluation, continuous assessment of every lab, out of how many marks it will be conducted, internal assessment, that is about the lab test, what are the minimum marks, everything is available here. So here O stands for open-ended experiment, which is again evaluated, okay, for the final marks. So anything you would like to know? Any doubts, clarifications? If you have any doubts, please unmute yourself and ask. Manish,
Yes, ma'am.
are you clear about the lab
Yes,
conduction?
ma'am. Yes.
Yeah. Anyone? Loshika,
Yes, ma'am.
anything you would like to ask?
No, ma'am. It's clear, ma'am.
Oh, yeah, fine. So shall we, yeah, Rashik. Rashik,
Yes, ma'am.
then would you like to ask anything?
No, ma'am.
No.
Nothing.
Okay.
Ma'am, sometimes I have internet issues, ma'am.
Okay.
That's what, ma'am.
Where are you from? Where are you from?
Ujjire.
Ujjire. Sometimes means how it is.
Like it fluctuates, ma'am. Not a proper connection, ma'am.
See, this proper connection problems you will be able to manage by now, right? Some
yeah, ma'am.
proper network you should take, right? Where you, whichever you get at your
Yeah,
place.
ma'am.
No.
That only Airtel we get, ma'am, here.
Okay. That also is not proper.
No, ma'am.
But now it is fine, right?
Sometimes it will be good, ma'am. Sometimes it won't connect only, ma'am. For labs and all, it is difficult, ma'am. For mobile, it is fine.
Oh, okay. What about laptop?
I have to do hotspot, ma'am. That I will not get, ma'am. Sometimes.
Oh, we will see. Anyway, you have the slot, right? You need not be present for entire slot.
Yeah, ma'am.
So whenever you have the proper connection in that lab slot, in between, it need not be as per your USN. You can call us and tell us about your problem, and then you can take up the this one, your assessment, whenever you have a proper connection. Okay. But yeah, interact. Okay. So you need not stay at your side and assume the things. Please interact. Feel free to communicate. We understand the problems, but we cannot. What everything should go on, right? Theory labs and all. So please communicate. Little bit adjustments we can do. Okay. So as I told, as per your USN, you have to join maybe 8 to 10 minutes taken for each students. If you don't have proper network during that time, whenever you have, you can directly call us and you can take up the assessment during that time. Okay.
Okay, ma'am.
So shall I close then? Anyone else having any problem, issues?
Yes, ma'am. Even me, ma'am. Same issue. Like to connect to laptop, it will be like difficult sometimes due to the network issues, ma'am.
So you don't have LAN, right?
Yes, ma'am.
LAN is not there.
No, LAN, like network issues, laptop, ma'am. to
You
connect
are
to
also sharing the hotspot.
yeah. Yes, ma'am.
We'll see. All the 3 years, it won't be like that, right? It may not be like that. Okay.
The thing is,
Oh,
ma'am,
this-
if I
this-
connect, like if I connect, like if to laptop, if I connect, like it will get over very soon, ma'am. Like the data will
No,
be.
see, the data problem, I am telling you, this is not the time to talk about the network issue and this one. Since from past 1 year, we are doing in the online mode, and it is strictly told from the college side. I think I am only showing you some excuse. From the college side, it is strictly told that all the students should have a laptop by now and a proper connection. What you will do if there is an internal and you have to upload something?
That I'll do it
You,
from mobile only,
you
ma'am.
should have done the arrangements by now. Okay, you should have done the arrangements by now. This is not at all a reason to share. Okay, so interact with this. Okay, and try to solve this problem of the network issue. Okay, the lab is conducted like this, and if you continue with the same reason, you will be losing the marks. Once in a while, fine. Okay, you have the lab for the entire semester. Once in a while, fine. But regularly, if you are telling about the network issue, I cannot do anything with that. Okay, we doubt that we will have any offline sessions. Okay, in this semester, looking at the present condition. So cooperate with this. Okay, try to do the proper arrangements. Okay. So once in a while, fine, we can understand, but regular problem, you have to solve it. You cannot say
Ma'am,
that
my house is
you cannot
located,
handle what?
my house is located in a village, ma'am. Like it's interior, ma'am. We can't help, like we can't do anything. Like it's very hard. Like sometimes, not always, but like I will try, ma'am.
Yeah,
I'll
that
try
is
my
what I'm
best.
telling. Once in a while, we can, if the weather condition is not proper, you may have severe problem. But all the labs, you cannot say like this. Once in a while, we can also understand. But you cannot say that I don't have data, I can't listen to the online class only, I cannot be online, I cannot be online to the lab session, right? You are present for the theory classes, right?
Yes, ma'am. Theory is fine.
Okay.
Like but connecting to laptop, ma'am, that's the problem.
Theory you are listening from the mobile.
Yeah, mobile only.
Anyway, you will be online only for 8 to 10 minutes. That's it. As soon as it is done, you will be leaving. So that is one advantage for you. Okay. So when you have proper connection, you call us and we will take up the assessments. But in that slot itself. Okay. In your regular lab session itself. Okay. So whatever, please communicate. We may not know what will be the problem on the other side. If you have cannot come online for your regular lab slot, not the session, that particular slot when you have to present, we can do some arrangements, but everything has to be communicated. You cannot simply be absent there. You'll be just marked as absent here. Okay. So that's it from my side. Thank you for attending. I'll close the session. Thank you.